welcome to another NES Mods video tutorial. Today I'm going to teach you how part of the process in making your own Game Genie codes. For this one I'm just going to be showing you the process in making a 6-character code. I'll be covering 8-character codes in another tutorial. So first off, I'm going to tell you a few things you need. You're going to need an emulator. For this video I'm using FCUXDISP just because it has a ability to test Game Genie codes and addresses and just makes things a lot easier on me to show you things, and a Super Mario Brothers ROM, which I'll let you find on your own. And we'll also need the code we're going to be the value is going to be turning into a code, and in this the 075A is the RAM, or is the address, and 03 is your change value, and it will grant you infinite lives in Super Mario Brothers. So I'll be showing you how to make your own Game Genie code that will give you infinite lives. Now that we have that, we can go ahead and open up the little program I made called Game Genie Encoder, which does what it sounds like, and just type in the value and encode it, and you'll see you get the code LAIEZY. So we know that's the code we're going to be needing, or well, that's what we'll be getting once if we've done everything and I've done it correctly. So now that we know that, we can go ahead and move out there. And first I'm going to tell you how the whole conversion works. Basically, when you have the code there, each of those things is a number, albeit you might think, what's up with the 8? That's not actually a number. This is hexadecimal, and if you do any work with NES or anything like that, and any further work or even programming, hex is pretty much going to become your primary counting system, because it's used, for memory addresses and the like. So it makes things a lot easier. Anyway, to transfer or to create the code, it's actually several series of bit shifts, but most people don't really get how to do that. And to make it simplified, there's another method that uses just a cipher and a few conversions. So go ahead and open up your calculator on your operating system, and I'm not sure about anything besides Windows, but if you go to View and go to Scientific, you'll get a layout similar to this. That's Vista and beforehand. If you're in Windows 7, you'll have to go to Programmer, which I think is nicer. Anyway, we're going to take our values 075A and 03, and of course anyone who's done any kind of math or any computer work really should know decimal, hexadecimal, binary, all those numbers are interchangeable and convertible. So 0, 0, 0, any number of zeros would equal 0. As you can see, if you're in decimal mode and type in 0 and go to binary, you get nothing but a 0. So we'll know that our first one is 0, but since you see INOP, the first letter here will have to be 4 values, so it'll just be 0, 0, 0, 0, which there's no difference between 0 and 0, 0, 0, 0. It's all 0. So we'll go on to our next letter, or number I should say, 7. So you can go back to decimal, type in 7, go back to binary, and it'll give you the value 111. And so we'll just have to add in a filler 0. And remember, in math, anything to the left of any zeros to the left of a number doesn't affect it. It's just a placeholder, I guess. So 111, and there's your 7. Then move on to your 5, and you'll get 101. So add your placeholder 0, 101. Move on to A, and for this, A is actually equivalent to 10 in decimal. You can know that by just typing in 10 in decimal and going to hex, and you'll get an A. And of course, if you want to go to hex and press A, you get that. And so you go to binary and you'll get 0101. So you don't need a filler 0 there, since it's 4 number or digits. So we go into our change value 0 and 3. We know 0 what the value would be. So 0, 0, 0, 0. And if you repeat the steps shown, you'll get that 3 is 1, 1. So just type in your 2 fillers and 1, 1. So now that we have all of our values written in, you can kind of see how the cipher may work. You might be getting an idea if you don't already realize. I corresponds to 0, N 0, and if you look around any letter, the number below is what it equals. So if you go back to the rearrangement of the cipher, you would just get the straight alphabet. So look for A in your cipher and you'll get 0, and then just look for BCD and you'll get 0, 1, 1. Then move on to E, get a 0, and then FGH, which is 0, 0, 0. So that's that. Now you'll look for I, that's a 0. Then JKL, and that's 1, 0, 1. Move on to M, and then NOP will be 0, 0, 0. And if you'll notice, usually the first letter will be one thing, and then the following 3 are actually in an order, so it makes it a little quicker than you might have thought at first. So then look for Q, get a 0, and then RST is 0, 1, 0. Move on to UVWX. You'll get a 0 for U, and then VWX is 1, 1, 1. And there you have your I guess translated values, or however you want to say it, once it's been run through the cipher. Now that we have that, we're going to need to do one final bit of decoding, and that's using this chart here. You can see what each of the values corresponds. Now, as you can see, 0, 0, 0, 0, or 0 corresponds to A, and it goes all the way to 15, which in binary is 1, 1, 1, 1, and it's F in hexadecimal. And there's 16 possible values you can get. So go ahead and go back to your translated, whatever you want to call it, numbers, and you see, look for 0, 0, 1, 1, which is also 3. You'll see you have L. Move on to 0, 0, 0, 0. You'll see you get an A. Move on to 0, 1, 0, 1. You get an I. And as you can see so far by comparing it to the value we got through the encoder, everything's coming out right, so you generally it seems we're doing it right, and of course we actually are. Then you look for 1000, 1000, if you want to say what it looks like. You'll get an E, and further proving we're on the right track. Then 0010, you'll see it's a Z. Finally 0111, and that's Y. And if you look, LAIEZY, and that's the results we got from the encoder. So we've translated it correctly, assuming the encoder was right, and I'd hope so. I've done enough testing to assume it's right for the most part. And so we have a value. Before you go off encoding or inserting, now that's done, we can just close out some of these things since we know what our value is. And alright, now we're going to go ahead and test out our code to see if it's working. So go ahead and open up FCUXESP and open up your Super Mario Bros. ROM and go to Tools and Game Genie Encoder Decoder. Go ahead and type in the value LAIEZY, and it will show you the value 875A. Don't worry about that. Just go to click Add to Cheat List. Now that that's happened, go to Cheats and look. For some reason, I have not been able to get it to work when it does the 875A. It could just be a problem with the FCUXD SP, but if you go and click the cheat, it'll give you the address 875A. If you change the 8 to a 0, which is the original value, and click Update, Add, well, you don't need to click Add, it'll just redo it, and then try clicking Reset Known Value. It seems to work. You may need to close and reopen FCUXD SP for this to happen, for it to work properly, but if you look, when you do that, it'll say you have 4 lives, which is one more than you're supposed to start with, which is an indication our cheat works. And if you look when you get hit, you still have the same number of lives. So we'll go ahead and do that one more time just to show you. And that's it. That's all there is to it. Question or comments, just go ahead and leave one on my website or below on YouTube, and I'll try and help you if you have any problems with this. That should be all.